So now what we can do is we have created our database with all of our information. And so now we can actually use it. Now we've gotten to the point where we can load this data in using Python, right? And so we're going to take advantage of the fact that we have this spreadsheet to go ahead and populate this database. And so this is going to be maybe the more complex part of your project, where you want to take a spreadsheet and load all your data in, because there are a lot of things you kind of have to think about in this particular process. So let's go ahead and get started with this. So in order to actually load the data in, I need to, beyond just creating this engine, I need to grab the select function. That is, I want to get data from the database, and I'll show you why that matters in a minute. And also from the SQLAlchemy ORM, I'm going to import session. And so this is going to be what creates a session to interact with the database, excuse me, that then lets me kind of load this data in. So now I'm going to come back all the way down to my main function, or the main script, the stuff that actually does things. And so now what I want to do is I want to go ahead and load in my metadata CSV or TSV. Now, there are a lot of ways we could do this. We could use pandas to load in the spreadsheet. We could use the CSV library. There's a lot of things. I just generally tend to do this kind of manually. It's not necessarily the most sensible thing, but it is what I tend to do. And so I'm going to say with open, this is going to be metadata.tsv. Reading it, the encoding here is UTF-8, and this is as RF, and then text is going to be rf.read. And I'm going to split this into new lines, and here maybe I'll call this lines instead of text. And then what I'm going to do is I'm going to say, oops, that's spelled wrong. There we go. Data equals line.split along the tabs for line in lines. Okay. And so now what we have is our metadata loaded in, and we can just print data 0. And this will just print the first line of this spreadsheet so we can see what the header looks like. And so we can see it has ID, title, genre, et cetera, and there's a bunch of like empty columns. That's an artifact of something I did a long time ago. We can kind of ignore those. Okay, so let's go ahead now and create a session that's going to let us ingest this data into our database. All right, so before we get into actually ingesting data into the database, I did want to point out that when we run this code and when it creates the database, it creates that local SQLite database inside the same folder that our code is running in. So you can see that we have this bibliograph.db file that's been created, and this is where all of our data is going to go. One really nice way of kind of assessing how well this worked and what exactly happened is to open this bibliographic database in a browser program. And one of the easiest to use is something called DB Browser for SQLite. And if you just do that, you open this file and take a look. What you can see is basically the metadata description, all of the metadata in this particular file. And so you can see that we have an author-work relationship, categories, commentator addition relationship, corpora. All of these tables have now been created, and they are ready for data ingestion. And so that's what we are going to do now. So the first thing I need to do is I need to create a session that I'm going to use to interact with my database. Now, I always like to do this with a context manager. So with session, I'm going to give it the engine as session. So inside of this, what we'll be doing is we'll be basically iterating through every row in the metadata and then processing it. So let's do this. So the first thing I'm going to do is I'm going to say for row in my data, and I'm going to skip that first row because that's basically just the header that describes what's going on. My shift button seems to be stuck for some reason. Anyway, the first thing I'm going to do is I'm going to check if the length of the row is greater or equals 1, because if it is, that means that actually there's nothing there. And so I'm just going to continue. And that just means that I'm going to skip it. And I'm doing this because sometimes this is kind of a messy spreadsheet, and sometimes there's just a row that's blank, and I don't want to, have that throw off any issues with what I'm doing. So the next thing I'm going to do is I'm going to kind of process my row data such that I just have an easy way of referencing it. Now, none of this is strictly speaking necessary. I could skip this and just directly use the row information, but I like to basically do things like, local ID. And this is going to equal row 0. And then I have title, and this is going to be row 1, and so on and so forth. So let me go ahead and do that. So the 4 branches is the 4 treasuries, 4-branch classification system that comes from traditional bibliographic studies. And that is going to be kind of one of the main things that I use as an organizing principle for this corpus, because that's what people did. It's a little messy. There are things there that don't belong to this in the data set, so it's going to require some cleaning up. But that's not what we're here for. Now, the authors in this metadata file, in cases where there's more than one author, they're separated with underscores. So we're going to need to remember that as we load our data in. Again, that's a bad thing to do in a spreadsheet, but such is life. That's why we're switching to a database. Okay, so basically this is just ingesting all of the data from the metadata file into these local variables that I am now going to use to actually generate my data. Now, this is a little bit convoluted because of the way that I'm trying to organize things and the way the data exists in the metadata file. But I'm going to need to keep in mind that I don't want to generate a new work if it already exists in the database. There are certain things, however, that will always be new, and so I want to create them every time I hit a row. And the first thing is an addition. So every row in this metadata file represents an addition of a text. And so what I can do is I can create that. I'm going to call it an addition object, and this is going to equal addition, which is my data class my class that I created above. And I'm going to provide information for this. So I'm going to say my research ID is going to equal this local ID. I want the title ZH is going to equal title. I want the origin corpus ID is going to equal corpus origin ID. This is not great practice here. Less than ideal move I made. I want to make sure that the character set is equal to this char set. But one thing to note here is that in my metadata file, I actually use trad rather than traditional. And so what I want to do is I want to actually set this to traditional if char set equals trad, else simplified. Okay, so basically this just ensures that it comports to that check that I set in my code up above. Otherwise, I would get an error. And then I'm going to say my notes equals notes. Okay, and so that is my addition object. So now I want to actually fetch work object if it exists in database, otherwise create it. Now, some kinds of ORM systems actually have a feature that lets you do this in one line. So Django in particular has a fetch if exists or create or something along those lines, but SQLAlchemy does not. But we can do this pretty easily on our own. So what I'm going to do is I'm simply going to say my work object, And I want to fetch it if it exists because I want to make sure things are getting associated properly. And so I can use session.scalars to basically fetch a bunch of results. And I'm going to use my select function, and I'm going to give it a work. And I'm going to say where work.title underscore zh equals title. And then I want to say, give me the first object. And so the advantage of first is that it says, if you have a result, give it back to me, but if not, give me none. Now, this particular syntax is SQLAlchemy syntax, and it basically is it's kind of a way of us writing Python instead of having to write a SQL select statement. And this is why this is such a nice thing to do. Then I basically say, if not work obj. So this basically says, if it doesn't exist, let's go ahead and create it. And I'm just going to create a work with the title zh set to title. Okay. And so this creates the work for me. But one thing to kind of be aware of is this is a little bit messy because of this issue with variant titles, and sometimes a work with one title, there are two works with the same title from different eras. This can present issues, but that's stuff that we would go in and manually fix as we kind of refine our data set. So the next thing we need to do is we need to do the same for era, because not every line in this metadata file has an era included. So I want to say if era isn't blank. So I don't want to do anything if the era is simply left off. And so I'm going to go ahead and do the same thing where the era object is session.scalars. And then I'll simply do select time period. So I'm selecting on the time period dot where time period dot value zh equals era. And again, I'm going to do dot first. And so let's make sure that time period, I'm pretty sure is value zh, but let's go ahead and double check that because that will cause issues later if I don't. Time period zh. Okay, so good thing I checked. And that should be time period zh equals era first. And then what we can do is we can say, if it doesn't exist, let's create it. So if not, era obj equals time period zh equals era. Okay. Now this data is messy enough that sometimes there are years in here, so that's going to cause some issues, but for the moment, we're not going to worry too much about it. So once we have an era, we want to actually decide, let's add this as our era of composition to our work object. So work object, and then period of composition is going to equal the era object. Okay. And we're going to do that also for our addition object. Period of publication equals era object. Okay. The next thing we want to do is we want to go ahead and get corpus information. And again, we don't know that this exists our first run through. So we say corpus obj. Again, the same thing. Okay, and so now we have our corpus object, and we need to basically say addition obj.corpus equals corpus obj. Okay, so that takes care of a lot of the relatively straightforward stuff, but the next thing we need to do is we need to add the authorship information. Okay, and so that goes with the work, but we need to be a little bit careful as we do this. So the first thing is we check if it exists. So let's make sure there's anything there. So if it does not equal an empty string, we can move forward. And so we can say for author in authors.split underscore, because this is just the way this particular spreadsheet is set up. And then I can basically do exactly the same thing, check it, and create it. And now what we need to do is we need to add the author to our work. And we want to check to make sure we haven't already included this. So we say if author object not in work obj.authors, then we'd simply go work obj.authors.append author object. And so this adds the author to the works list. Okay. Now we would want to do the same thing if we had information on editors and publishers, which unfortunately is not in this spreadsheet. I have it elsewhere. So we're going to kind of skip dealing with those addition level people relationships. So the very last thing I need to do is I need to deal with the categorical information. And this exists in two columns in my database or in my spreadsheet. We have our 4 treasuries classification or our 4 branches classification under genre, and then this subcategory, which comes from mostly the people who created the complete library of the 4 treasuries, but a lot of it kind of comes from online, and there's a lot of kind of loosey-goosiness in it. But for the moment, we're going to store all of this under a subcategory object type. We need to check, is this data present? And then if there's multiple versions, and then we go ahead and add it. So I'll go ahead and fill this out and fast forward through it, and then we can continue. So one thing I'm doing here is I want to make sure that my category contains this type of category 4 branches, because that's what this column is. So I'm going to include that information here. Now, one thing you may have noticed is I'm typing this same structure over and over again. This would probably be a really good use case for just writing a function that does this kind of fetch or create process. But I just haven't done that. So here as I create it, if it doesn't exist, I need to specify that type of category to make sure that is contained there. And then if it's not already associated with the work, then append it. And so the next step is to do the same thing for those subcategories. And so I can actually just copy this and paste it and then adjust it properly. So here, all right, this is not 4 branches, but for subcat. And then here, I'll make sure I replace 4 branches, and then I'll change this to FS, 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 and FS. And this should be FS there too. And then this should be this should be, we'll call it Suku subcat, right? It's not exactly the 4 treasuries subcategories, but it's close enough for this instructional video. Assuming I don't have any typos anywhere, I actually think we should be good to go. FS object. And so now all we need to do is now we need to actually save this information to our database. And so we need to first add everything to our session. And so I'm going to add all, and this is going to be a list of all the objects that I need to add. But because basically everything is associated either with the work object or the addition object, I actually only need to add the work object here and the addition object, and it will handle everything else for me. And then I'm going to go ahead and do session.commit. And assuming no typos or any mistakes, this should now actually ingest all of our data. So I'm going to run it, and we'll fix any errors that come up. Okay, so here we have an issue where the relationship between the work and date of composition, there are no foreign keys linking these tables. And so I need to ensure that referencing columns are associated with a foreign key or foreign key constraint. So let's go back up to work, date of composition, and fix this issue. Okay, so let's look at our work. We have date of composition, relationship, cascade, all. Okay, so here Here we can kind of think about what the ideal way of linking these two things are. So I think the easiest thing for us to do is, in fact, define this relationship in date of composition, because it needs some reference either to an addition or a work. So let's go to our dates here, and we can say date type, precision reason, and let's make just here, we can do addition, we'll just call it addition ID. And this is going to be a mapped optional int, and this is going to be a mapped column and foreign key, and that should be additions.id, and we're going to need one of these for work also. And this should help us with this particular issue. Work ID, optional mapped, works.id. Okay, let's see if that fixes our problem. One thing to note here is we may actually need to delete our database and then rerun it, because sometimes as you make these adjustments, it doesn't make the updates. You have to actually kind of go into the database, delete it, and then recreate it. So I'm just going to do that very quickly by going over to my file browser. And you can basically see here, I'm just going to go to bibliographic database and move to trash. And then I'm going to kind of come over here and rerun this code. And then say, now we have this same issue with the period of publication. So we have fixed the date of publication issue, if I am correct here. Yeah, so we fixed this issue. So now we need to look at addition period of composition. And addition object. So we'll do addition. And we will do period of composition, period of publication. Here, this issue is period of publication ID. Because what's happening here as I do this is that this second one is overriding this first one. So that should fix that. And again, I'm going to go ahead and do this delete, move to trash, and try this again. Let's make sure I've saved this just so it... Okay, here we go. Scalar result object has no attribute, SA instant state. Okay, so here we have addition.object.corpus equals corpus ID. And so we need to basically see... okay, the issue here is that I forgot to grab the first one. And that should fix that issue. I'm just going to look for my sessions, session.scalars, and make sure I add this first. And it looks like I forgot it in a bunch of places, which is fine. Okay, that's fixed now. Okay, so here we see value ZH is an invalid argument for category. And so we're looking at it right here. And it should be category ZH. None type is not callable. So here we see we're starting to do some generation and some inserts. Oh, then here we have, this should simply be FB obj equals category. That's simple enough. This is just what happens when you move quickly. Okay, value ZH again, category ZH. Okay, so now we're making progress. Not null constraint failed works title English. Okay, that's easy enough. That means that I accidentally forgot to specify that the works English name, these should all be optional. And this is a change in the database schema, so I need to make sure that I delete my database and redo it. And we're off to the races. And so all of this is getting loaded into my database, and it is, if you're looking at my file browser, you can see kind of this information get updated as the file size of bibliograph.db increases. And so I'll fast forward to the end. This isn't going to take more than like a minute or so, but we don't want to sit here and watch it. This would also likely populate more quickly if I didn't have echo set to true to kind of spout out the SQL that's generating the data, but it's nice to see that it's working. And there we have it. So now our database has been populated with our spreadsheet. And so I am going to kind of just come back over to the DB browser and make sure that this has actually happened. So I'm going to open the database. This actually has an older one that's opened. So an earlier version that I was working on. And let's come to database video, open bibliograph DB, open. Okay, and so now we can browse our data. And look, we have author work relationships. That's cool. We have people information. And of course, there's a lot of null data here because we haven't inserted it. We have our corpora, Kanseki, OpenLit, Daijiko, Wenxian, Wikisource, and so on. There are a couple texts from CTEX that I got for a specific project that I was working on. We also have editions. This is where the bulk of the data is. Here's all our titles, and it tells us all of the stuff that we want. So great, this worked. So what I'm going to do, I think in the next associated video, which will not take 4 years to produce, I'm going to go ahead and make an interface for this database with Flask. And so one of the things about working with these kinds of databases is, for example, that in a view of this information, I wouldn't necessarily want to see period of publication ID. I would want to actually see the name of the period of publication, okay? And I would also maybe want to add pinyin and English translations and all these kinds of things, but we are going to be building a quick Flask interface for this. And so, you know, look for that to come out at some point soon. I want my students to have access to this before the end of the semester. So hopefully maybe even next week, but we shall see. So thanks for staying with me this long. Hopefully this is useful. Hopefully it helps you think through how you build data models based on spreadsheets and how you might approach a research project that involves database building. So I will see folks in the next video. Thank you so much for watching. Take care.